Hi, I'm Alex. When you're setting up your marketing mix model in Meridian, one of the first data decisions you have to make is granularity. Should you model at the national level or break it down to the geo level? In Meridian, we strongly recommend using geo-level data whenever possible. It allows you to use hierarchical models that utilize a concept called partial pooling. To understand why this matters, imagine you need to estimate the ROI for 4 different cities. If you run a separate MMM for each city using only that city's data, you are doing no pooling. The problem is, you might not have enough spend data in a single city, say San Diego, to get a reliable estimate. Your credible intervals become very wide, meaning we aren't very confident in the result. You might think, well, these cities are somewhat similar. Let's just combine all the data into one big pool. This is complete pooling. While your interval is narrower because you have more data, you've introduced bias. You're assuming every city behaves exactly like the national average, which we know isn't the case. This brings us to Meridian's approach called partial pooling. It is the compromise between these two extremes. In a hierarchical model, we assume that while every geo is unique, they share a common average. We use the common average to inform the individual estimates. Think of it as regularizing toward a common mean. If a specific geo, like San Diego, has especially noisy data or wide intervals, the model borrows more strength from the other geos and pulls the San Diego estimate closer to the national average. Mathematically, we say the ROIs come from a shared distribution. Think of this shared mean, the red line, as a magnet with a gravitational pull. The strength is stronger and more confident as you add geos with strong signal that behave similarly to one another. For a noisy geo like San Diego, the magnet is stronger than the local data, so it pulls the estimate toward the group mean. But for New York, it has a tight interval and strong signal, so the magnet doesn't pull as much. The data itself decides the balance, finding the sweet spot for every geo without you having to manually weigh it. So practically, what does moving to this geo-level hierarchical model actually do for your Meridian results? First, it increases your effective sample size. More data points mean tighter credible intervals. Second, it captures variability in spend. At a national level, spend might be consistent week over week, but across geos, per capita spend can fluctuate. This variance is critical for estimating nonlinear effects like saturation and the Hill function parameters. Third, it improves our estimates for time effects, like trend and seasonality. Because we have multiple observations per time period, an observation for each geo, we have data to model time effects for each time period. Finally, it helps reduce bias from hidden confounders. By modeling at the geo level, we can often reduce the correlation between media spend and omitted confounding variables. Now, we realize you might not always have geo-level data. If your data is aggregated to one geo, we call this a national level model. To be clear, this doesn't have to be a nation. It's just shorthand for a single geo model, whether that is a whole country, a specific state, or just one region. However, the benefits of geomodeling are so strong that we recommend a specific workflow if your data is mixed. Let's say you have sales data by geo, but TV spend is only available nationally. Instead of aggregating your sales up to the national level, we advocate for imputing the national channel down to the geo level, for example, proportionally based on each geo's population. This allows you to keep the rich granularity of your geo-level channels, rather than flattening everything to the lowest common granularity. By using Meridian's geo-level Bayesian hierarchical modeling, you're getting an estimate that balances local nuance with global statistical power. Check out the documentation linked below for more details and implementation guides. Thanks for watching.